Hello, hello again. So right now, what I want to talk about is function transformations. In particular, this video is going to be about horizontal shifts. So what I'm going to try to do is I'm going to try to show you. By the way, so this is going to be my toy function. I'm using a toy function for ease of discussion. Okay. And what I'm gonna try to convince you here is that if I take this function as my f of x, okay, I have my little f of x table here, and I have my function drawn out here. What I want to convince you is that if I take f of x plus 2, that it will shift the graph of the function to the left by 2 units. And so therefore, what I'm claiming is that g of x equaling f of x plus 2 will be the graph of f shifted to the left 2 units. Okay, without further ado, let's begin. Okay, so I'm going to label this axis -4, -3, -2, -1, 1, 2, 3, 4, 5, 6, etc., etc., etc. Now, for ease of reference, above here, I'm going to plot what the values would be. I'm going to call this my x plus 2. I'm going to call this x plus 2. It's not an actual axis, but I'm going to put it there as a way of labeling what will actually go into the f. Okay? Because here is my x. For x equals -4, what is x plus 2? Well, -4 plus 2 is -2. If I plug in -3, I'll get -1. If I plug in -2, I'll get 0. If I plug in -1, I'll get +1. If I plug in 0, I'll get 2. If I plug in 1, I'll get 3. If I plug in 2, I'll get 4, right? So 4 will be right there, etc., etc., etc. So you might ask yourself, David, why are you doing this? The reason why I'm doing this is because I want to make the calculation of my values of g and consequently draw the graph as easily as possible. So the f is going to be evaluated at x plus 2. So I graphed this, this little number line of x plus 2 over the corresponding points of x, because that way I can make an easy comparison between what's going to go inside the f of x, what's going to go inside the f, to what's going to go inside the x. Okay? So for example, so in our table for our function f, we only know the function values of f at these x values, and of course we know how to draw the figure by duplicating these things. Oh, this is not part of the graph. I'm sorry about that. Right? Okay. Yeah. Okay. So now, so we know that at x equals -2, in other words, we know from this table that f of -2 will equal to 0, right? So here, if I want this to equal -2, then I already know from my x plus 2 chart that that occurs here, which corresponds to the x for the g of -4. So if x is -4, right, then g of -4 will be the same as f of -2, which will be 0. Okay? Let me walk you through again with the next point. Okay. So if I take x equals -1, then I know that this will be -1 here, because this is my x plus 2 line. Well, that corresponds for my g of x equals -3. Okay? And we know that the value that f takes on there is 1. Okay? And if we continue like this, well, I know that x will be 0. I know that this will be 0 at x equals -2. And so g of negative 2 will be f of 0, which will be 0. I know that if the inside here is equal to 1, right, then my f will be negative 1. But where will the inside here be 1? Here at x equals negative 1. So at negative 1, we will get negative 1 here, okay? If this inside is equal to 2, which occurs here at x equals 0, then my corresponding y value will be 0. And finally, if this expression equals 3, which is this, that will occur for us at x equals 1. And so at x equals 1, our y value will be 1. Okay? Okay. I hope that argument was like clear. Just to make sure it's absolutely crystal clear, I'm going to show you how we can calculate that explicitly right now underneath before we actually draw it in. But what I was trying to get you to see was that by drawing this line that captures the shifting of the x values, I'm able to see how the old coordinates here, these x's, can be related to the coordinates that I'm going to plot the g graph in. Okay? So these are the coordinates. This x-axis is the x-axis I'm going to use to plot the g, and the x plus 2 is a way for me to look at what these values of x correspond to with respect to these. Okay, I hope that argument wasn't too muddled, and I hope that you guys have enjoyed it. In any case, let me just verify for you that these are actually true. Okay, so what is g of negative 4? Well, by definition, that will be f evaluated at negative 4 plus 2. So in other words, like this, right? That's how my function is defined. I can simplify this inside though. Negative 4 plus 2 is negative 2. And then I can look at my table. Aha, my negative 2, if my input to f is negative 2, my output will be 0. And so we can see that indeed this is correct. What about this one? By the same reasoning, g of negative 3 is equal to f of negative 3 plus 2. Why is that true? Because of this. My function that has name g and takes an input x, and what does it output? It outputs the function f evaluated at that input x plus 2. Okay? Then, what is negative 3 plus 2? Negative 3 plus 2 is negative 1. So this becomes f of negative 1. And you can see that that will give us, for x equals negative 1, f is 1. So I have just confirmed this second point. I could continue to do the rest, but if you want, you can do that for yourself. I'm just going to stop right there. And now I'm going to draw the graph so that we can see the new graph. So I'm going to draw my graph G in black. I know that at negative 4 it's 0. At negative 3 it's 1. So let's call that 1. At negative 2 it's 0. At negative 1 it's negative 1. Let's call that here. Okay. And then at 0 it's 0 here. And then at 1 it's 1. Like this. Then I'm going to copy my shape over. Okay. So it's going to go like this, like this, like this, and then like that. Okay. Now, so in other words, let me put this here as a legend for my graph. The G is in black. Now, for comparison's sake, I'm going to graph my original f in. I know that f of negative 2 is 0. so that'll be right there. At -1, it's 1, so that'll be right here. At 0, it's 0, which will be right there. At 1, it's -1, which will be right there. At 2, it's 0, which will be right there. At 3, it's 1, like this. And so I can see that it will be, let me see here, like this, like this, like this, and then like this. By the way, I'm sorry that I'm like not drawing the dots as well, but it's because I don't want to corrupt the marker prematurely. But now I want you to notice something here. In blue, okay, in blue, I have the original f. Notice, this graph has indeed been shifted 2 to the left, as we predicted. And so now, we can generalize from this. We know that in general, if I have a function g of x, and I write it as f of x plus h, assuming h is positive. So in other words, like let's say f of x plus 2, f of x plus 3, f of x plus 100, then this will be a horizontal shift to the left by h units. Okay? And there you have it. And by the way, this rule is one of the rules that we're going to use when we're doing transformations of functions. And we're gonna have a few more rules before we actually proceed to doing some example problems. I hope you've enjoyed this video, and we'll continue soon. Thanks.